Right, good morning, everyone. How are you guys? All good? Um, just give me a moment. Right, just to recap what we covered yesterday, and then we'll continue from there. So we touch upon some basics around how OT system, operation technology is different from IT systems, because it's not just about data security, it's also about understanding what kind of impact an attack can have on the physical systems, right? So we'll continue with that part, and we'll try understand some more points regarding how IT system is different from OT or ICS. When I say ICS, I mean industrial control system. Industrial control system is example of operation technology. One of the reasons is, as we've seen yesterday, Purdue reference model, OT system or ICS system comprises IT plus OT. Yeah? So there's a boundary that we call DMZ, that boundary that keep your IT and OT parts separated. Yeah, we'll talk about more why we need to keep them separated and what kind of security you need to consider in each part of the system. So in terms of IT, it's all about data, right? Generally, IT systems, whether you are talking about working through mobile, working through laptop, we're always generally talking about what data has been transmitted from one end to another end. And then we'll talk about something called CIA, right? What is CIA? Right. So we talk about saying confidentiality, integrity, availability, which is very kind of true in an IT system. Now, when we talk about OT system, the story is slightly different. In OT system, most of the data that we need to be reached at recipient in certain amount of time. So there are applications, there are protocols which requires data to be transmitted in few milliseconds. Yeah. So in IT system, mostly the data is sensitive. So we say, okay, let's encrypt data before we send it. You encrypt data at one end, transmit it over the network, and then you receive it and decrypt it. So that's why we say confidentiality is very important for an IT system. In OT system, availability is the key. One of the reasons is, as we talked about yesterday, SCADA system. Yeah, so what it does, it captures all the data and then pass this data to its central system, run the algorithm. So for example, if we are talking about power system or smart grid, we have power algorithms that we run just to see power flow, whether everything looks fine, devices are working properly, the level of voltage and current that should be there is kind of working perfectly or not. If your data is slightly modified in IT system, does it impact? It impacts, yeah? If you want to transmit 1,000 rupees to a person, but then by mistake you say out of 1,000 you say 2,000, it makes the difference, yeah? However, in OT system, it might not be the case. As long as your system is stable, even the data is modified, even the data is slightly malicious, when you pass this to a system runs its own algorithms to see if everything looks fine, it doesn't bother. If the system is still stable, even if I have to do minor things just to balance everything in terms of voltage, current, power, the system is still fine. Right? That's why confidentiality is not the key here. Availability is really important. If you're not receiving data, you don't know what's going on your system. And now we are talking about a very large system, country-wide infrastructure. So it's really, really important to know what is going on. So you sense data, you have sensors that help you, collect data, and then you process it to see every few minutes to understand whether everything looks fine, or if not, then you need to obviously take certain actions in terms of commands, sending commands and managing that. So that's one of the key. So I'll be talking about other things. For example, patches. So generally we say in IT systems, as long as you see a vulnerability, you just patch it as soon as possible. Yeah. For example, when a vulnerability is found in a system, most of the time manufacturers of that product, they release patches and ask people to update their system, right? Which is straightforward. You just restart your device, whether it's laptop, workstation, whatever. In OT system, it's not the case, because OT system works in a real-time system, right? For example, you can think of, you have a manufacturing unit that requires all the time electricity, and there's a production going on. Every few minutes you build, you are producing thousands of products. Suddenly you see there's no electricity. Yeah, cut. What will happen? There's a downtime. You will lose production, you will lose revenue. It will incur a lot more cost for you, even for a few minutes. So if you need to patch an ICS system, it's not straightforward. Rather, it's really difficult to find out when can you patch, because these are the real-time systems. They are working all the time. You can't really bother. You can't really afford kind of downtime. That's why patching ICS system or OT systems is one of the key problems that people are still solving. Yeah. Antivirus. There are a number of antivirus for IT systems. For OT system, possibly there's no kind of customized antivirus for OT system, but people are still using IT systems, antivirus that are built for the IT system. But then, in some way, they are working as long as you think about the IT part of the ICS system. But then for OT system, we need to build more customized antiviruses. Antivirus means intrusion detection system, basically. And these systems should be more context specific, depending on what scenario we are talking about, what kind of protocol, what kind of devices we have in place. System administration. Okay, in IT system, as we know, there's a system admin having root access, and then for the users, depending on your need, you get those kind of access, right? For example, as a student, you have certain access, but certain restrictions. Faculty members might have better access than you, and so on and so forth, right? In OT system, again, that's another issue is, as I said yesterday as well, most of the devices, so these are the legacy systems. Most of the devices comes with default passwords or no passwords, right? So if you have hundreds of devices from one manufacturer of same kind, they will all have the same password. Anyone who knows the password can access all those devices. So you can't really have control over the way you can control IT system, in terms of access. We talk about the availability. In terms of protocols, generally all the IT systems are based on TCP/IP protocols. What is TCP/IP? Right. And in terms of ICS system, there are a number of protocols there. Some of them relying on TCP, but they're not really TCP/IP. Yeah? Many of these protocols are vendor specific. For example, if the vendor is from the European countries, they have very different protocols from vendors from Americans. They are kind of different protocols. So if you are bringing devices from both of those countries, it becomes much harder for you to understand, kind of making sure the interoperability and how this will kind of compatibility fit into your system. Impact. When something goes wrong in your IT system, what can go wrong? People might compromise your device, steal your data, modify the data. Does it have any impact on people? Safety? No. Yeah. On the other hand, an ICS system, potentially it does have impact, not just modification of data, but the consequences, how the attack can impact the system. It might destroy your devices. It might lead to a fire. It might lead to a flood. It might lead, depending on what applications we are talking about. Yeah, so it might have a life-threatening scenarios. And that's where ICS systems are more sensitive to handle. Yeah, so I talk about this confidentiality. So in ICS system or OT system, we say availability is the key priority. Then the integrity. At some point, we need to know data is correct. So that's where we talk about integrity. What is integrity? Right. So when we send any data over the network, we want to ensure the data is received correctly without any modification, any alterations. Yeah. And lastly comes with confidentiality. There are very few instances where we need confidential information. Otherwise, availability is the key. We want to make sure we receive data every few minutes, every few hours, so that we can understand what's going on. Yeah. All the ICS system have something called safety instrumented system. So it says when something goes wrong, we have a module that will enforce system to do something, right? For example, when the voltage goes up at your home, what happens? MCB trips down. Yeah? It will automatically cut down so that it doesn't harm your appliances at home. So all the ICS system have these kind of safety system in place. In the worst case, it can save you. It will cut down all the connections. In IT system, there's nothing like that. Yeah. Segmentations, network segmentation. In IT system, as we talked about yesterday, we intentionally create networks, multiple networks for our enterprise, so that we can segregate them, we can isolate them as per our need. If one of the part of the network is compromised, you can still kind of keep safe the other part of the network. In ICS system, also segmentation there, and we talk about this. If you remember Purdy reference model yesterday. Yeah. So Purdy reference model having 3 labels, 0, 1, 2 from OT side. Then we have DMZ, demilitarized zone. That is kind of interface between OT and IT. And then we have an IT system where we have two levels of IT system. In terms of protocols, IT system, I think you know all these protocols, HTTP, yeah, TCP/IP, FTP. What is FTP? File transfer protocol. UDP, user data. Okay. SMTP, simple. All right, so you know all this. On the other hand, on operation technology, we have something called Modbus, Field Bus, DNP3, and BACnet. So these are more kind of popular protocols depending on what regions we live in. Most of the IT operations are stochastic or probability based. However, operation technology more are deterministic. We need data to determine what's going on, and then based on that we make certain decisions. Patching, IT system easy to patch. As I said, it doesn't really affect downtime, especially out of the working hours. You can always maintain your system. You can restart whatever you like. But an OT system, you can't do this because they are working all the time. Application, IT system mostly time sharing, OT system real-time systems. Skilled personnel available for IT system. People used to work IT systems, it's kind of a very old system. OT system, sector specific, people are skilled. For example, if you say power system, there are a lot of power engineers, electrical engineers. However, people who understand cyber security in electrical systems are not many. Yeah? People who understand security in healthcare, security in transportations, not many. Because we were not taught these things. However, the way we are heading, we need to consider security of those systems because these systems are, as I said, critical in nature. Safety, security focus for IT system is the confidentiality, in OT system availability as we talk about. Authentication methods For IT system, there are multiple authentication methods, right? You can do, there's a password-based authentication, yeah, where you can insert user ID and password. Might be, you may have a phrase rather than password. Sometimes people say insert a phrase. So it's easy for you to remember, but also difficult someone to crack it, because it's kind of really long. What else? It could be image-based authentication. As I said yesterday, you can, when you register, you can have a sequence of images. You read, you learn that pattern. Every time when you log in, you select those images in that sequence too. What else? Biometrics. So you have fingerprints, facial recognition, yeah, and many others. Then you also have writing patterns, yeah. So the way you write, the way you type things, the way you hold your device. So those kind of methods also really popular in OT system. There's kind of no authentication really. There are only few authentication as long as connecting to VPN, connecting to devices, but then accessing those devices, I said they all have default passwords. So as long as you are part of the system, it's very difficult to detect, you know, who is the person accessing device X. It's very difficult. Life cycle, generally IT system technology changes very rapidly. Every other day you come to see, oh, there's a new language, there's a new technology. Yeah, people are talking about Gen AI, then a DeepSeek, and you know, every morning you got to see new things. On the other hand, OT technologies, old systems, proprietary systems, legacy systems, they are there. So they generally, their life is around 20 years for devices and systems. And their communication mostly machine centric. They were not built for TCP/IP, rather they were built so that machine can talk to each other, can send data, you know, within those systems without having the need of internet. So that's one of the reasons you see for IT system, mostly all the other devices connected to the internet all the time mostly. But in OT system, we don't have really internet. So if we recall the yesterday, possibly I'll also talk about a substation and control center scenario where you see that devices are deployed as substations, right? We are sitting at control center. Now there's a communication from control center to the substation. But then at substation, there's only one or two devices which are connected to here. And sometimes we use dedicated lines rather than wireless connections. So it's very hard to crack them. But then at substation, we have RTU that transmit all the data from substation to the control center. At substation, then there are other devices, and we have sensor that can sense the data. Those devices are not connected to internet. Yeah? So let's say you have 100 of devices. They can all sending their data to one device, and this one device is only connected to the internet. In the worst case, you can just attack this device. You can't attack part of the network, right? So in that sense, OT technology doesn't use much internet. It doesn't require much internet. Just the roughly overview. So you got network technology in terms of field bus, industrial Ethernet, wireless. What is Ethernet? Your wired connection, yeah? That generally comes Ethernet. Okay, so layer 2. Then you got wireless technology where you can connect your devices remotely, like without wired. And then you got field bus op. So field bus mostly in OT parts, we got something called Modbus RTU. So these are the protocols. We are not going to detail, just to give some names so that you're familiar with. Modbus RTU, then we got DeviceNet, then we got BACnet, which is Building Automation Control Network, then we got DNP3 distributed network. So DNP3 is more popular in America. So in US they use DNP3, but in European countries we use Modbus protocols. Yeah? So that's why they need to customize. So if they are manufacturing in Europe, devices will come with Modbus protocols. If they're manufacturing in the US, they come with DNP3 protocols. Industrial Ethernet, for example, Modbus TCP version is for Ethernet connections. And then you got Profinet, EtherCAT, and others. Similarly, wireless technologies, Zigbee, again, depending on the range that you need. Zigbee, Bluetooth, LoRaWAN, they all IoT technology, yeah, for IoT devices, 6LoWPAN, and so on. So there are a number of technologies there, number of protocols there. depending on which part of the world you are living in, what is the requirement, how much range you need in order to transmit data from one end to another end. Yeah? And based on that, we decide on technology and so on. You know topology, what is ring, bus, star, mesh, yeah? Okay. Now, one of the things that we generally understand and we derive is try to understand what are the possibility of attack and how can we categorize attacks in a broad, so that we can build a broad understanding that what could be the potential nature of the attack, what they can exploit, in what way they can attack our system. So generally people, researchers have come up with something called attack taxonomy. It's kind of a comprehensive version where they say, what is this threat source, what could be the nature of threat, what kind of malware can inject, can attack my system, what part of my system they can target, in what way they can target, and what could be the likelihood impact. So let's say there's a malware X, so we talked about Stuxnet yesterday, for example, yeah? Targeting nuclear plant, centrifugal systems, yeah? How they can be injected? USB drives, if they have internet connection, maybe spear phishing emails and so on. So they can target the system. What kind of impact they may have? If it gets into the system, if it floods, kind of it was a worm, it can really damage the whole system. So it's really high impact. So that's how you decide on and try understand the big picture. And we talked about yesterday something called proactive. So we said reactive, how you react to the attack, and then proactive, saying we want to be prepared. We don't just want to wait something bad to happen. Rather, we want to be well prepared to understand what can go wrong, and do we have enough and good solutions to tackle. Yeah. In order to do so, we go for something called cyber risk assessment. So we do risk assessment just to understand what type of attack can harm the infrastructure and what their probability look like. And in worst case, something like this happens, how they will impact. So you try quantifying things, yeah, so that we can get a sense whether this kind of attack is a low risk, it's a high risk, it's really emergency or critical risk, right? And one of the difference with IT system is mostly IT system, the risk is static. It doesn't really vary whether it's a daytime, whether it's a nighttime, or whatever. However, on the other hand, on OT system, it could vary. So as we talk about maybe peak hours, peak off hours, right? Whether there's a huge demand, a lot of people are connecting. You have, as a company, a lot of pressure to fulfill that demand in that region. And at that point of time, if there's an attack, that might be a little critical than peak off time where you have more kind of bandwidth to handle it. So in order to understand the risk assessment, we have certain methods to follow. One of them is called CVSS, Common Vulnerability Scoring System. So this is one of the ways to quantifying risk. So generally, we look for something called probability of occurrence. Right? So let's say I'm talking about attack X. I'm saying this attack might, because of the nature, the way we connect our device X to device Y, maybe it's a wireless, maybe we can't have IDS there, because that data needs to be sent in few milliseconds. You can't really have encryption there, for example. Yeah. So you can identify then part of the reason. This region is really secure. I can apply encryption. I can apply other security control, because there's no latency requirement, strict latency requirement. Yeah. On the other hand, I might have a system where we need to send data really fast. We can't apply encryption. We can't really looking into the other things. That might be critical when someone target it. One, these systems are really fast. Second, the data need to be sent in few milliseconds. what if you attack those devices as a DOS attack and disable those devices so these devices don't send any data? So building your understanding, and then there's a kind of a scoring system which says what is the likelihood of this attack. So you can rate out of 5 out of 10. So let's say out of 10 I'm saying probability is really high, number 8. Yeah? What kind of impact it can have? Assuming something like this happens, how it will impact your system. So you also rate it out of 5 out of 10. So that's how you come to a conclusion finally. That's likelihood multiplied by impact, and this is my final score. And then final score somehow help you understand where you belongs to. So if the score is 0, no risk. If the score is, for example, 0.1 to 3.9, it's a low risk. 4 to 6.9, medium risk. 7 to 8.9, high risk. And 9 to 10 is a critical. So for different scenarios within your system, you do this kind of analysis, and then come to a point where you see all the risk scores for the scenario you think, possible scenarios. And these scenarios will help you to understand which of the attacks could be more critical to your enterprise, to your company. And we need to make sure we need to have more focus on critical and high risk. Because for low risk, we believe that we already have some kind of solution that can help us in worst case. Medium is maybe we need little more effort, but then high and critical we might not have any solutions or enough solutions to handle it. And then you start thinking what kind of solution we need in order to defeat this kind of attack, in these scenarios. So generally CBSS is used in IT systems. And then people start criticizing, saying how this fits into OT system, because OT systems are much more than just the IT systems. Then researchers come with something called industrial vulnerability scoring system, which they build on the top of CBSS. So they are not two different systems, but extension of CBSS is IVSS. Whereas you also need to consider environmental factor in terms of industrial, so it's an industrial process environment and impact. So you also need to consider that in which environment, which sector we are talking about, what kind of devices are there, what kind of processes are there, and what are the criticality level of those processes and kind of sequence. So they have something called local accessibility. They say what kind of devices and assets might have access. So if there's an attack, what they can access. Because as I said, in OT system, there are several devices having default or no passwords. Once you get into the system, you can have access to all range of devices. Network segmentation level. How did you segment your entire IT/OT network? And if there's an attack, which part of the system it will impact? Then they got consequences, saying process visibility consequences, process monitoring consequences, and process control consequences. Something like this happens. Can you control the process? So in one of the tutorials, we will talk about Ukraine attack, where attackers targeted power systems, and the attack was so powerful that no one could control it. So we also need to understand what is the level of controllability we have. If something bad happens to us, can we fix it and take the control back? Let's say there's an attack that can compromise one of the devices. Start sending some control to trip down something. Is it possible I could isolate that device? Is it possible I could block those commands? If I can do that, that means I can take control back. So I'll put in place some controls, some security controls, solutions, and I'll take control back. I'll fix that attack. So that is minor, I would say, low risk for me, because I know how to handle those kind of scenarios. On the other hand, if there's a coordinated attack, attacker compromise multiple devices, I might not be able to understand what's going on. And for those kind of scenario, I can't really I'm not really prepared. So if that is the case, then what could be the consequences? In worst case, what attacker can capture? What kind of impact they can create over the system or the part of the system? So again, you range it with numbers. And then last, they say industrial impact. How does this impact system production? How does this impact reliability, safety of the system, and then financial losses? Yeah, so you all rate it and then come to the kind of scoring system. So here you say base score, then you go adjust to accessibility score, what as an attacker, what they can access, what part of the system and devices they can access, and then you have impact or criticality level. And then you put all together to get the final score. So this is a very kind of practical and an applied method that generally most of the company do use for the risk assessment. And this will help you to understand what are the critical points in your system that needs more attention. And as you got to know more coordinated attack, more sophisticated attack, you want to do this exercise again and again and again. Yeah? When WannaCry came, people start doing with this WannaCry. What will happen if there's a WannaCry that can, what is WannaCry? Yeah? It's a ransom attack. What does it do? So what does it do? It gets into your system and encrypt your files. Yeah? It will say if you pay X amount, I will decrypt it, otherwise I'll delete everything. So let's say it goes to a banking server and encrypt all the files. So I have encrypted all the files. If you give me X amount of money, I'll decrypt it. If you don't give it, I'll delete everything, all the data. So as a customer, you will panic. Yeah? Unless they have backups. So that's one of the reasons most of those companies having sensitive data, they always have backup. Every day they have a backup. So that in worst case, someone hacked this, we still have data in some way. But sometimes companies don't have, particularly small companies. Yeah? That's why in order to perform those kind of attacker need to be smarter to understand what kind of data they need to hack. You know, where that data resides. And you target those systems with those kind of attacks. Now, when the ransomware kind of attack came into the picture, there's a project called No More Ransom. So if you Google it, nomoreransom.com or something. I don't remember the exact name, but No More Ransom was a project. And researchers around the world, they come together saying we want to develop decrypted tools. It says, if you've been targeted as a ransom attack, here are some codes, decrypted codes. You try with those codes. So they all are freely available. You can download them and see if you can decrypt your files. If yes, that's all free of cost. If not, you have to deal with the attacker. Yeah? If those are really important, then you have to pay. And ransom attack is one of the most popular attack in terms of financial losses. Companies really, they had to pay a lot of money. Now, one of the key things in OT system is system interdependencies. System interdependency in the sense, in IT system, generally though there's no kind of direct dependency, we might, so one of the typical scenario of IT system may be financial sector, for example. Yeah? People are kind of making transitions, you are making payments, online, offline, whatever, and then they need to kind of deposit or withdrawal amount from the database. Yeah? So that works with something called ACID. Have you been database? Have you studied database? So you know ACID property, or yeah, how the transaction, what happened when your transaction fails, it's rollback, everything and so on. So we have certain property to maintain in database, right? On the other hand, and it doesn't have really direct consequences unless when we talk about a transaction, there's a commit property. Something goes wrong, then we roll off everything, you know, so that we can start from where we were. In OT systems, we might have system dependencies. So let's say one process, outcome of one process is the input of the another process. So it might be the case. Yeah? The outcome of one device, we are feeding it to the another device. Outcome of one process feeding to the another process. Always happen in OT system. And those kind of system interdependencies really matters here. If someone hacks one device, change its outcome, you are feeding the incorrect outcome to another device or another process, it will lead to another incorrect outcome. And we end up with making incorrect decisions, right? So in OT system, it's also really important to understand system dependencies. When you also calculate risk, you also consider these interdependencies in the picture. What is the cascading nature? Is there any cascading scenario in my company? Is it possible when if attacker compromise some device, some process, can it lead to failuring other devices, other processes? So those are the things really important here. And you will understand that once you understand processes. By looking just devices and network topology, you won't be able to understand. You have to understand what's going on, what processes we are running, yeah, and how these processes are feeding in input and outputs from one another. And this will help you to actually understand what are the devices and systems, processes which are interdependent. And then only accordingly you calculate the risk. So this is just the scenario of typical power system, the way it looks like. If you see this, so that's how power engineers look at and try to understand systems. So we'll be talking about it more in one of the slides later on. So again, depending on which sector we are talking about, we need to try to understand the big picture. Another difficulty with OT system is most of the devices are third-party vendors. Yeah, for example, Microsoft. For IT system, they sell their own computers, yeah, their own operating systems inbuilt with their own browsers, which is not the case in OT systems. In OT systems, most of the devices that we have are from third-party vendors. And third-party vendors possibly come with some, for example, we say power system, they are the electrical engineer. They come here, then connect everything, and goes away. Something goes wrong, you are you're completely relying on those. Come and fix, something has happened. You don't know what to do, how to do. Your team is not having expertise of there. Because you are a company of healthcare, for example, yeah? But you need power. You have manufacturing unit, but you need power plants, and so on. So the number of reliability there, for example, dependency was system reliability. What is reliability? So we look into reliability, resilience, productivity, security. What is reliability? You just want to say how reliable your systems are.
In anyhow, if one device is got compromised, then there is a way to communicate with other device. We can still communicate in our system.
Yes, that could be one thing. What is resilience? Now, resilience we define in several terms, but general, system resilience, network resilience, cyber resilience, the different terms around resilience. Robust to attacks, yeah, maybe. Yes, ideally we say resilience means even the system is under attack, the business should continue. So it should not be like someone attacking and everything is kind of gone. We need to, and that's where we are heading, saying we need detection tools, which is fine. So if you can protect your system, you have really nice security control that can handle all kind of attacks, excellent. Which is ideally not the case. Then say, okay, if we can't protect, can we detect those things? So we have detection tools, IDS, and so on. But what if we don't? So we talked about yesterday how some types of attack, APT attacks, can bypass IDS. So if we are not able to detect, what do you want to do? Then we try to understand how they can impact. What will be the worst case scenario if they hit our system? Yeah. So we try to understand the impact. And then we want to design system in such a way the system can heal itself. If system is under attack, we want to automate that process, response process, so that they can start doing some, reconfiguring things so that they can mitigate the impact of the attack. We might not stop the attack, but can we mitigate the impact? Can we reduce the impact so it doesn't harm massively. Yeah. That's where we are heading. So I will be talking about resilience in more detail in one of the talks, one of the lectures. So we talk about, so they might have bespoke applications, more specific customized applications. We might have third-party applications, system vendors, supply chain. Supply chain is also kind of really important in OT system, right? What is the example of supply chain? Very simple example, how you get the food. How we get the food? Someone is growing it, cropping it, needs water, needs sun, energy. Then they need to store it somewhere, so they need storage. They need transportation to carry it somewhere else. Then there's a financial argument, how you buy and sell product comes to you with some tax, X, Y, Z, and then how we get it. So there are several labels that come across in order to get the product finally. What if there's an issue around water treatment plants? What if they don't get water to their farms? What if there's no transportation? Yeah, there's a delay in transportation. There's a strike going on. Let's say something coming from China or some other countries, and there's a strike going, and that's a lot happened in Western world, especially during COVID, and so they were not allowing to enter vehicles in their countries. There's a shortage of food. What will happen? Price will go up. Yeah, people was going to the supermarket and getting everything that they can have. So the supermarkets were empty, and whatever they had, prices are really high. And you have no choice just to pay because there's only a few things to buy. So if there's something, even the slightly issue in supply chain, there's a huge panic. In a similar way, supply chain is very critical for these kind of critical systems. Yeah, might be the power system is relying on a manufacturing plant, or the other way, might be they're relying on transportation sector, and so on and so forth. So impact on one sector might directly or indirectly impacting other sectors. If you don't handle, if the attack is really massive, it takes months or days to recover. It has a direct consequences on other sectors as well. And finally on people. Yeah, that's why we also need to kind of keep in mind these kind of things. Obviously, it's part of the government strategies and policy. They want to make sure supply chain is really kind of quick and working. So we talk about all these things. Strict requirement of high reliability, high availability in real-time response in OT sector, complexity of patch management, complexity of interactions, heterogeneity of CPS component. So we talk about saying that we have different types of devices that generate different types of data in different formats. So you can't really directly use it. You need converters. You need to bring all in the same format in order to have access of your data. And these are legacy devices. We don't address security issues. So these devices were built, these systems were built for the communications, for generating power, electricity, and so on. At that point of time, they did not consider security as because these systems were not connected to the internet anyway. Yeah, so they were not really concerned about cybersecurity. But now we are connecting some of these devices to internet. That's where cybersecurity comes into the picture, and we need to add a security layer on the top of what we have. And unfortunately, most of those cybersecurity experts, they don't understand these systems. So we need to build our understanding. We need to really understand how can we help those companies in order to have better security posture and awareness. Now, AI and cybersecurity, I talked about yesterday. There was a separate lecture, so I will not go into this. Adversarial attack, we talked about yesterday. Yeah, you want to check what it does? So generally, you want to, as an attacker, you attack machine learning models. Right? Maybe you feed malicious data, so it trained with that, create a loop, create a backdoor entry for attackers to get into the system. Yeah, or the other way. So you're pretending kind of benign data as malicious, or malicious data as benign. So you train your system, and you can train it both ways. Okay, what is the cascading impact? So I talk about this. So for example, interruption of telecommunication. You don't have communication. There's no mobile connection. There's no telephone lines. There's no internet. What's going to happen? How will you communicate? Can you think of something like this? Yeah. Let's say if you don't have any connections for a month. It's just here, no connection, no internet, no cell phone, nothing. What can you think? There's no transport for a month. Will you be able to come here every day? Huh? No. There's no power for a month. What will happen? We can't think of those scenarios even, yeah? So that's why it's also important to understand the cascading consequences. For example, interruptions of telecommunications. It says impact of all level of communications, severe impact on financial services. So those are kind of, now we do a lot of online things. If there's no internet, everything is down. Companies will be in losses. As a consequence, what will happen? When they come up, prices will be higher because they need to then back, recover what they have lost. That all happened after COVID. During COVID, companies had a lot, huge losses. And when they came up, especially airlines, prices were doubled. They're still doubled now. And once the price is up, it doesn't go down. So very rarely happens. So they were all in recover mode and then profit mode, and want to be where they were planning their profit and so on. So those kind of massive consequences have a huge impact on us, directly or indirectly. Interruption of transportation. It's a foodstuff and fuel delivery interrupted. Potential hazard material compromise. Now, when we have a shortage of fuels, petrol, diesel, what happens? Prices will go up really high. Yeah, people are selling black. And when something like this happens, it starts chaos. It impacts on your economy. Yeah, it's a direct impact on populations. So that's what we talk about, saying these critical systems are not standalone. It doesn't like if there's a one power company down, you don't have any impact if you're not use electricity. It has impact directly or indirectly. It will impact whoever using the power, and they will add cost to it. And if you're buying any product, anything out of it, you'll pay more. Yeah. Now, one more point I want to talk about here is threat modeling. Now, threat modeling is a really important way to understand a threat. One of the popular method, so there are a number of methods, I'll just talk about one. One of the popular method is called a STRIDE model, STRIDE modeling, which stands for spoofing, tampering, repudiations, information disclosure, denial of service, elevation of privilege, right? What is spoofing? Right. So it's hard to distinguish whether it came from, it's a legitimate or it's a fake. So attacker spoof, for example, if your intention is to look at the IP address to recognize whether a certain packet is coming from the right source or not. Attacker might spoof that IP address, fabricate a packet with the same IP, and then send it. When you receive it, you start believing since it came from the same IP address, this is the correct packet. Yeah, but practically it's not. So spoofing, detecting spoofing now easy. Tampering, and one of the solutions is spoofing identity. What you can do is saying appropriate authentication put in place, protect secret data, and don't store secrets. Okay, one of the thing, how does you, so we have password, for example, when I go and log in here on your laptop. Where this password stored and how does it store? In what format we store it? In your laptop, mobile? Huh? Does it store in a plain text? Encrypted text. Because if you are using encryption, then where's the key? Encryption, you need a key, yeah? You use key to encrypt it and the same key to decrypt. So how do we? No problem. Yeah. So generally, we store passwords in the form of hash code. Hashing, you know hashing? Yeah, we'll be talking about hashing in more detail anyway. So password stored in hash. So that's why we're saying don't store your credentials on your devices. If you're storing them and someone have access, maybe remotely, maybe because someone is your friend, maybe you don't log off your device, someone might have access to those things. So those kind of more protection thing, but then saying in order to stop spoofing or control spoofing, you have to have more authentication mechanisms in place. That might help you. What is tampering? Tampering of data, what is that? Modification, altering, yeah, altering your data. So say appropriate authorization. Authorization means who can access that data, right? You want to control who can access what resources. So we have a lot of, for example, university system, you have number of labs, number of devices, screens, computers, whatever. Now we want to restrict who can access what. As a student, if you are from computer science, you might have access to the laboratories of computer science, not everything, because you don't need to have access of mechanical, for example, right? So on basis of that, you decide what user needs what kind of permission on what resource. So in digital terms, when we say permission, it could be read or write a file. Someone can just read the file. Someone can write or edit the file as well, right? Hashing. So hashing is one of the way to ensure integrity. We'll be talking in a minute. MACs, I'll be talking, what is MAC? Okay, I'll be talking all these things. Digital signatures and tamper-resistant protocols. So generally tampering means we wanted to ensure if someone has tampered data, we should be able to recognize the data has been modified. Yeah? If that is the case, you generally discard that data because it's been modified. Now, third thing is repudiation. What is repudiation? Right. So repudiation property simply says if I'm sending, let's say I'm sending a message to person X. If that person has received this message, he should not be able to deny it, he didn't receive. On the other hand, sender should not be able to claim that I did not send it. So there should be some footprints that can ensure that this data was created, this message was created by person X. Yeah, and we ensure this through digital signatures. You can put some timestamps at what time this message was sent. When you receive an email, it always says date and time. Yeah? So it's not the time of the sending the message, but the receiving, what time you received. Information disclosure. Yeah. Sometimes information is confidential. How do we handle it? Applying encryptions, limiting access, who can access things, privacy enhanced protocol. If data is sensitive, we want to ensure privacy is still there. By looking at data, you won't be able to relate or able to identify individuals out of it. Denial of service. Okay, so again, denial of service attack depends generally on what type of DOS we are talking about. So DOS attack could be you are flooding a lot of messages. Yeah. So let's say there's a client-server architecture with a number of clients there, and they are sending data to the server. Server need to handle all the data, all the requests, look at the queries, send response back to the clients. Now, what do you have too many clients, and they are just sending random data? Yeah. So generally, client-server model, they do have, if they are based on TCP, for example. In TCP protocol, we have something called handshaking. Yeah. So how does it work? So client will send a request to the server. Server will acknowledge, send to the client, and then client is expected to send the actual data. Yeah? And in order to make it more correct in a way, server wants to know that this is the real client, for example. Yeah? One of the way of attack, so understanding of DOS attack is, as a client, what client needs to do? Generate a query and then send it. It might take just 1 minute. But for server, if server is handling 50 clients, 100 clients, 1,000 clients, it will take time. So it's very easy to perform these kind of attacks. There's a one device handling a lot of queries. It will take time for to handle, put a queue where all the requests will add in, and you handle one after another. So what is the protection? And then again, DOS could be different types of attack. If you're talking about flooding, application label, DOS might be at as physical label, jamming attack we call it. You jam the device, no bits transmit from here and there. How do you stop DOS attack? So generally we understand that from a source, this is the on average request we get per day. Yeah. If you're receiving too many requests from one client, it might be the case. Now, one of the things we wanted to ensure when we handle DOS attack is we also want, if this is a legitimate client, we also want client to utilize certain resources. It should take certain time to send us a request. So if you see a client flooding you with the messages, you look at the IP address, everything looks to be legitimate. It's not the malicious client, but for some reason it's just flooding. You might want to make that flooding a bit difficult in order to connect it properly. So as an attacker might, they don't have any intention to complete the handshake process, 1, 2, 3. They just say send it, server send request back, and then client doesn't respond because it doesn't want to connect, just a malicious client. It just keep sending. What will happen? Servers having a queue, they're having a list of what are the open requests there, because server is still waiting for client to respond to the third communication so that they can complete the handshake. Yeah? So they will always wait for the client. So if those are those kind of instances, we want client to also utilize certain resources. So what server can do, they can send a puzzle to the client. Give a puzzle, give them some time to solve it. If they're able to solve it, they might be the real client. Yeah? If not, they will be occupied. So you solve this and then send it. So you're not kind of bothering until they send it. So this is one of the processes you can restrict or reduce the flow of packets. Yeah? And obviously, you can take appropriate control in terms of authentication, authorization, and so on. You can apply filtering, quality of service, and so on. Last is elevation of privilege. You want to reduce access of resources. You want to give the rights to individual who really needs those resources, right? Not everybody else. For example, in this class, who's going to use this screen? Who's going to use other screen? Maybe the people, they need to have access. Not everybody in the class, in this class, for example. Yeah. So that's how you need to follow the principle of least privilege. You want to reduce access to the resources, and whoever needs to have access, they should be having access, not anybody else. If they need it, they can request it. So sometimes we give this permissions for temporary purpose. Somebody needs this for 1 day because there's an event going on. So you give them access for a day and then take it back. Sometimes ex-employees, they still have access to many things, and they can misuse it once they go out of it. So we also need to ensure once they exit from an organization, they don't have any permissions, they don't have any access. Yeah. Okay, so let's have a break. Let's have a 10-minute break. We'll come back and then we talk about typical scenarios with some examples. So all this will be kind of a little high level. I wouldn't go in much detail. I'm not sure how, what is your understanding on cryptography and other things. But I'll give you a sense about the idea, about the solutions and so on. But then we'll pick more practical scenarios, real-time scenarios, how they look like and what kind of problems are there and how can we solve these problems. Have a 10 minutes break, we'll come back.